Saturated, supersaturated, unsaturated describe solutions qualitatively. Dilute and concentrated also describe them qualitatively. These are relative terms, a dilute solution or a concentrated solution. Concentrated has more solute, dilute has less. And that's all it means. Well, qualitative descriptions are nice, but scientists like numbers. So we're going to learn two different quantitative descriptions for solution concentration. One is mass percent concentration. Mass percent, or M/M percent concentration. This is the mass of the solute, the part, divided by the mass of the whole thing, the mass of the solution, times 100%. So we've got this pattern here, the part divided by the whole. What's the part? It's the solute. That's the smaller part, divided by the mass of the whole thing. It's mass because we're looking at the mass of each of these. There are other percent concentrations that are mass volume and volume, but we're not going to talk about those. We're just going to do mass. Another way to express this is it's the grams of solute divided by the quantity, grams of solute plus grams of solvent, times 100%. Because the solute plus the solvent is the solution. And sometimes they'll give you the mass of solute and the mass of the solvent. So then you have to put these two together to get the mass of the solution. So these equations are important. What is the mass percent concentration for a solution containing 5.57 grams of strontium chloride in 225.0 grams of water? Well, we need to remember what mass percent means. It's grams of solute divided by grams of solution times 100%. In solving a problem like this, a good approach is to look at what they're asking for, mass percent concentration, and if there's an equation for that, identify what that equation is, because that's going to tell you what you're looking for, instead of just pulling numbers and doing random mathematical functions on them, right? So this is what we're looking for, grams of solute and grams of solution. We've got two numbers here. Let's pull those numbers out and identify what they are. So we've got 5.57 grams of strontium chloride, and we've got 225 grams of water. So one of those is the solvent and one is the solute. Right, those are the two parts of a solution. Which one's the solvent? It's the one that there's more of, the water. And often it's the one that's a liquid as well. So this is the solvent. That's grams of solvent. Then the other one must be the solute, grams of solute. Did they give us the mass of the solution? No. Can we figure it out? Yeah, all we have to do is add those two numbers together. So 225 plus 5.57, those are the two parts. You just add them together. 230.57. That is the mass of the solution. So now we see that we need this number and this one. And so we can plug those in up here. 5.57 grams divided by 230.57 grams times 100%. How many significant figures should that answer have? 3. This one on the top has 3. This one on the bottom has 4, but even if you didn't recognize that, the 3 is going to limit you. And so I'm going to round this to 3 sig figs, and this will be 2.42%. That is the mass percent concentration. Could you ever have a mass percent concentration that is greater than 100%? No, you couldn't. Because the mass of part of the solution can't weigh more than the entire solution, right? That's like saying, well, you know, in that kindergarten class, 120% of the students are boys. What? That doesn't make any sense, right? It's impossible. If you come up with a mass percent that's greater than 100, you messed up somewhere and go back and check your work. The most common mistake on a problem like this is that students will overlook that this is grams of solution, and they'll divide by the mass of the solvent instead of the mass of the whole solution. So that's a mistake to watch out for. Any questions? We can use the mass percent as a unit factor to solve problems. Remember that percent means parts per 100. Percent. Cent refers to 100. So let's look at 25.0% sodium hydroxide, and let's write factors relating sodium hydroxide, water, and the solution. So 25, pick the marker first. 25.0% means 25 grams of solute per 100 grams of solution. 25 per 100. We could also tip that upside down, because it's saying that 100 grams of solution contains 25.0 grams of sodium hydroxide. They are equal. How could we get the amount of water? Well, if we're looking at 100 grams of solution and 25 is sodium hydroxide, how many grams is the water? 75, right? So there are 25 grams of sodium hydroxide for every 75 grams of water. And we could also write that one upside down. 75 grams of water per 100 grams of sodium hydroxide. Not 100, 25. I got this 75 by recognizing that the solution is the mass of the solute plus the solvent. Well, let's throw that up here. So 100 grams solution equals 25 grams sodium hydroxide plus the grams of water. And so I solve for that question mark by taking 100 minus 25. Could we relate grams of water to grams of solution? Yeah. So if I had 100 grams of solution, how many grams of water would be in there? 75. 75 grams of water. Or we can also tip that one upside down. 100 grams of solution. Chemists get tired of writing entire words, and so we abbreviate things. So look at that. That one percentage, 25%, gives us 6 unit factors. That is very, very useful. Any questions? So we need to be able to solve mass percent problems. So one type of mass percent problem is calculating the mass percent concentration. We already did an example of that. You need to identify the masses of the solute and the solution. You may have to add two numbers to get the mass of the solution, and then you use the equation that we learned. You plug the numbers in, you calculate, you get the mass percent. The other types of problems will ask you to find the mass of the solute, the solvent, or the solution, and they'll give you the percent. So what you do then is you write the percent concentration as a unit factor, and then you do unit analysis. You take the quantity that you're given, you multiply by the unit factor, and you get the answer that you need. Let's do an example. A 7.50% potassium chloride solution is prepared by dissolving enough of the salt to give 100 grams of solution. What is the mass of water required? So we have 100 grams of solution is our given quantity. 100, let's just start that over. 100 grams of solution. And what do we want to find? The mass of water, grams of H2O. So we can actually go directly from grams of solution to grams of water using a unit factor that we get from the percent concentration. So we need something that relates grams of solution and grams of water. Well, let's just write down the most obvious one, 7.50 grams of potassium chloride per 100 grams of solution. But that's not the unit factor we need. We don't want grams of potassium chloride, we want grams of water. Well, if we're talking about 100 grams of solution and there's 7.5 grams of potassium chloride, how many grams of water are there? 92.5. So 100 grams minus 7.5, 92.5 grams of water. So there are 92.5 grams of water in 100 grams of solution. Is that going to help us convert from grams of solution to grams of water? Yeah, that one's going to work. Oops. So 100.0 grams of solution. I'm just doing unit analysis. I want grams of water on top, and I want grams of solution on the bottom because these guys are going to cancel out. I'm going to look at this unit factor. This time it happens to be right side up, but we might have written it upside down, and we can just look at it and see that the grams of H2O, we need to put 92.5. What we did down here tells us which is on top and which is on bottom. So we don't need to worry, are we multiplying, are we dividing? The units are just going to tell us what to do. So we need to put the 92.5 on top and 100 on the bottom. And so that comes out to 92.5 grams of water. And some of you may look at that and say, well, duh, I could have figured that out. Well, yeah, because this is 100 grams, but this will work with any amount of solution. Any questions? A couple more examples. What mass of potassium carbonate is dissolved in 10 grams of 2.5% potassium carbonate solution? So 10.0 grams is what we're given. That's grams of what? Solute, solvent, or solution? It says 10 grams of this percent solution. So it's the solution. And what are they wanting us to find? Mass of potassium carbonate. That's this guy. So we want to go to mass grams of potassium carbonate. By the way, there are other ways to solve these problems, and if you're good with percentages and you can do it a different way, you're very welcome to do that. So we need something that relates grams of solution and grams of potassium carbonate. Well, what does that percent mean? 2.50%. Grams of solute per 100 grams of solution. So it's 2.50 grams of potassium carbonate per 100 grams of solution. And that's exactly what we need, isn't it? So 10 grams of solution. It's important to write grams of what? Because all of these have grams. And if you don't write grams solution, grams solute, grams solvent, then you're not going to know if you get your units mixed up. So we want grams of potassium carbonate on top and grams of solution on the bottom. The units tell us that. We look at our unit factor. 2.5 grams goes with the potassium carbonate, and 100 goes with the solution. So we get 10 times 2.5 divided by 100, 0.25. That's grams of potassium carbonate. These are very practical calculations. Mass percentages are used a lot in medicine and biology because they're easy to make up. You can measure the quantities by weighing. So this would say if you want to make 10 grams of this particular solution, you're going to need 0.25 grams of the potassium carbonate. Dextrose. Dextrose is just another word for glucose. A lot of times if you're going to have surgery, they'll give you an IV with 5% dextrose just to make sure that you've got enough, sugar in your blood and to help you deal with the surgery. So a 5% dextrose solution. How much of the solution contains 5.36 grams of glucose? Well, we've got two numbers here. The percent is going to be the conversion factor, the unit factor. And so where we're starting is with the other number. So 5.36 grams of glucose. And what do they want us to find? Mass of solution. So we need a unit factor to relate these two. And let's start with the 5% here. 5% means 5 grams of glucose per 100 grams of solution. We need grams of glucose, grams of solution. This has both of them, and so we're good. That's our unit factor that we need. 5.36 grams of glucose. We want grams of solution on the top and grams of glucose on the bottom, because we want those to cancel out. Units first, and then the units tell us where to put the numbers. So 5 is in front of glucose. So this time 5 goes on the bottom and 100 goes on the top. And so we've got 5.36 times 100 divided by 5. And the calculator says 107.2 grams of solution. If we're going to be careful with our significant figures, what would we round that to? One significant figure. 100. So 100 grams of solution yeah, I just really ran out of room over there. Or you could write 1 times 10 to the 2 grams of solution. Any questions?